Hey guys, here's part one of the Graphing Polynomials booklet. The second part will be later in the week. So the first example we're going to go through is graphing x cubed minus 7x plus 6. This question breaks things up into a couple of steps, almost like the Desmos activity we did last week, and then graphing it is at the end. So first things first is we're going to need to factor this. It makes life a lot easier for the x-intercepts and stuff like that. So we're going to go 0 is equal to x cubed minus 7x plus 6, and we're going to try to find the x-intercepts that way. So we're going to do factor theorem, which tries to find a remainder of 0. So again, we should usually start off with plus or minus 1, and just note that we could also do plus or minus 2, plus or minus 3, or plus or minus 6, because of the constant on the end, right, for the integral 0 theorem in that case, okay? Make sure my phone's not bouncing around too much for you guys. Okay, here we go. So now we're going to go, let's go f of 1 first. Okay, it's an f of x function. We got 1 cubed minus 7 times 1 plus 6, which is 1 minus 7 plus 6. That's 0, which is a good sign, which means that we can end up using 1 as our factor. Okay, so we're going to do synthetic division now, which will give us the divided part. Okay, we got 1. There is no x squared, so I have to put 0. Negative 7x plus 6. Do a quick synthetic division here. Make sure I have 0 on the end, which I do. So to fully factor, I've got x minus 1. Remember, it's always the opposite sign of what you're dividing by, times x squared plus x minus 6, which is equal to x minus 1 times x plus 3 times x minus 2. Okay, so that is our fully factored form. So now if I needed to find the x-intercepts, the zeros, the roots, which in this table is just in the middle here, I can get it all from that portion when I make y or f of x equal to 0. Okay, so that's 1, negative 3, and 2, all from these becoming 0. Okay, what's the degree of the function? It's 3. What's the leading coefficient? Positive 1. Okay, I don't usually have to put the plus sign or the negative sign for our numbers, but or the plus sign for the numbers, sorry, of course negative signs would, but just to remind ourselves that positive is going to change our end behavior, okay, which happens now. It's an odd degree, it's a positive leading coefficient, so it is going to be going down in Q3 and up in Q1. All right, and the y-intercept is always the constant value, which in this case is 6. Okay, so now on our graph, we'll be able to put those dots on there at this point. Okay, so we have zeros at negative 3, 1, and 2, and the y-intercept is at 6. We did this in the last WebEx meeting, so for those that missed it, this is what we call a sign diagram. Okay, the sign diagram is going to allow us to figure out what is happening with y. Okay, so these are all the y signs, and it's in between all of our x-intercepts. So we're going to go from negative infinity to negative 3, negative 3 to 1, 1 to 2, and then 2 to infinity. They each have like a section number. So section 1, 2, 3, and 4. How do we figure that all out? Well, if we have section 1 as an example, you're going to find a number between negative infinity to negative 3. So let's say negative 4. And you're going to take that number, you're going to plug it back into either the original function, but it's probably a lot easier to use your factored form and just multiply. Okay, so negative 4 minus 1 is negative. I don't need to know the exact number. Negative 4 plus 3, also negative. Negative 4 minus 2, also negative. And that answer is a negative number. Okay, so the first section from negative infinity to negative 3 is going to be negative in the y direction, right? So again, this is the y direction that we're looking at. Okay, second section, let's go x is equal to 0. It could be negative 2, it could be negative 1, it could be a decimal if you want to, but try to make it as easy as you can. Okay, so 0 minus 1 is negative, 0 plus 3 is positive, 0 minus 2 is negative. I have a negative times a positive times a negative. 2 negative signs gives me a positive value between negative 3 and 1. Okay, so very quickly now, between 1 and 2, let's go with 1.5. You get positive times negative, gives you a negative. And finally, x equals 3, positive, 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 positive at the end. It's common for this to alternate signs as you go in the y direction, but it is not necessarily always the way it works out, as we're going to see in a future example. All right, so now that we have all this information, we know that we start down in 3, we end up in 1. We also have where our y values occur. Okay, so from negative infinity to negative 3, we have y in the negative direction. Make sure it's at a slight angle as you go. Okay, now we want to go in the positive direction from negative 3 to 1. Now that we're going from an x point to another x point, we want to create ourselves like a mini parabola going from point to point. In this case, we're also including the y-intercept, so I highly encourage you to go a bit above the 6. That's usually how these graphs work out. Doesn't have to be perfect, but if you went like this, it would be pretty hard to reach the 6 at the top. So go above the 6 and come down. 6 is not necessarily your highest point. We don't bounce back up. We are going into the negative between 1 and 2. Doesn't have to go super low. Just go like a mini parabola between 1 and 2. And from 2 to infinity, we're going up. And again, slight angle as we go up from 2 to infinity. So those are the steps. Factor down, fill out the table, or if you didn't have the table given to you, just understand what your end behavior is and what your intercepts are, and then fill out the sign diagram. The second page you guys can do now if you want to pause the video and do the second page on your own. Now I'm going to do the third page with you. This is getting into the second topic of the booklet, which is dealing with multiplicity of our graphs, okay? So for example, if I have this graph given, it's fully factored for me. I find the zeros, negative 1, 2, and 4, right? It doesn't matter that there's exponents on each one because negative 1 plus 1 is 0 and 0 squared is still 0. Okay, so you're still finding the zeros the exact same way. Multiplicity to start off is pretty straightforward. It's literally what is the exponent on that bracket. So the multiplicity of this one is 2, this is 1, and this is 3. So don't forget about the invisible exponent on those ones there. And I'm sure you can figure out the rest of the table there. You have the notes for you. Just be careful with one like this with the 2x plus 1 and the x cubed. Let's actually do that one quickly. X cubed is 0. This is negative 1/2. And this is negative 3. This has a multiplicity of 3, 1, and 2. And you guys can fill that one out on your own. Okay? More importantly, just going to quickly discuss what happens with the actual picture of the graphs themselves. Okay, a multiplicity of 1 has this type of looking graph. So all 3 of these zeros have a multiplicity of 1. They basically go directly through the 0 or the x-intercept. Okay, they don't bounce back, they don't flatten out, they just literally go directly through the x-intercept. Okay, once you get to a multiplicity of 2 in this one here has a multiplicity of 2. This would have a multiplicity of 1. It's not in your notes, but if you want to make a note of that, you can. Okay, this is what we call bouncing or bounces off the x-axis. And what that does is it basically keeps you in the positive direction and then bounces back right into the positive direction again in the y direction. So if I was doing a sign diagram as an example between whatever this is, negative 2, I guess, between negative 2 and 2, I'd be positive from negative 2 to 2, and then 2 to infinity would be positive again. So that means that it would be a squared bracket and it bounces back into the same direction. Okay, and then finally, the last one is a multiplicity of 3. Okay, that is this intercept there. All right, in this case, we call it flattening out. Okay, and flattens out means that it's not necessarily a straight line. It's actually kind of weirdly curved in towards the intercept and then curved back up, but it does kind of have a flat line in between that and then keeps going through. So unlike a multiplicity of 1 that goes directly straight through the graph, this one flattens a little bit in that stretch and then goes up to the top. Those are the 3 multiplicities we have. You technically could have more than that. The more you get in a multiplicity, the more flat you get in this case. But for this year, we're just going to focus on multiplicities of 3, maybe like one example of 4, but that's about it. Okay, so now let's take a look at the last page here, or page 4, sorry, the last page you guys can do on your own. Okay, so we're going to take a look at page 4. We want to state the zeros or the roots and the multiplicities, and then what does the factor look like. So in this case, I have 2 zeros, 1 at negative 2 and 1 at 1. The multiplicity of the first one seems to go directly through. There's no flattening, there's no bounce back, so that's a multiplicity of 1. The x-intercept at 1 goes from negative and then bounces back to negative again, so that's a multiplicity of 2. Remember to switch your sign in the bracket, so this would be x plus 2, that's the factor. This would be x minus 1, okay, that's the factor as well. This is x plus 2 to the power of 1, this is x minus 1 to the power of 2. Okay, and then on this side, we have a 0 at negative 2, multiplicity of 3, x plus 2 cubed because it flattens out, and then a 0 at 4, multiplicity of 1 because it goes directly through, and you get x minus 4 to the 1. Okay, finally, last thing in this video today is just to fill out this table on the bottom for this example given. All right, so we have from top to bottom here, what are the zeros with their multiplicity attached? We have negative 4, and it goes directly through, so that is multiplicity of 1. We have negative 2, also a multiplicity of 1, and x equals 2, and look at that, multiplicity of 1 yet again. All right, so none of these flatten out, none of these bounce back, so they all have a multiplicity of 1. What is the factors of the function with the least possible degree? In this case now we have x plus 4, x plus 2, and x minus 2. Basically, the least possible degree just means that we are not going to have, again, the 4s or the 5s, etc., unless we have more x-intercepts. Remember the combination, if I have a degree of 4, I could have 4 x-intercepts. In this case, we're just going to look at it as a multiplicity of 1 across the board, and the least possible degree that we could have is 3. We have 3 x-intercepts here. Technically, if the graph got moved up slightly, we could technically have 5 x-intercepts if that happened, but because of the way the multiplicity works right now, we can only have a degree of 3. That is the least possible degree. You can't have a degree of 2, you can't have a degree of 1, but you could have a degree of 3. What's the sign of leading coefficient? Well, because we're opening down, so down in 3 and up in Q1, then that means it is a positive sign of the leading coefficient. Okay, so that's kind of your end behavior backwards, right? Seeing the graph and then seeing what that a value would be or the value out front. And then finally, intervals where the function is positive and where it is negative. This is basically your sign diagram. We're just going to do things a little bit differently in this case. We're just going to use round brackets for the sake of argument, but you could technically, I guess, when you reach an x-intercept, put a square bracket. We're just saying from negative infinity to negative 4, to negative 4. That is negative. Then you go from negative 4 to negative 2, which is positive. Negative 2 to 2, that is negative, and then 2 to infinity is positive. So in this case, make sure you're always using your intervals with your x-intercepts, and then all of these signs are equal to f of x or just y. Okay, so it's asking where is y positive and where is y negative. So now you guys will be able to do the last page on your own.